All right, I think we'll just go ahead and get started now. So here to talk about what's keeping things simple. So bringing my slides to work. All right. So about me, my name is Tim Robinson. I'm a test systems engineer. Been in the Cincinnati area for my entire career. I wasn't born here, but I've basically raised in this area. I've been personally using LabVIEW since 2005. Uh, maybe at the end of 2004, I'd have to go back and figure out exactly when. But almost all my time has been in the aerospace defense. Started out with actual space systems and then moved on to FAA, which was less regulated. Made a lot of people laugh at that one. Then after a few more spots, I am now at Northrop Grumman, which I'm in an interesting position because the group I'm part of, we actually do a lot of different work for other parts of Northrop. So it gives me a lot of variety in what I see. So that keeps things fun. On the forums, I'm cross rules. I am a Knight of an Eye. I am fast approaching 30,000 posts. So I'm waiting for that new shield, hopefully by the end of the year. LabVIEW architect, I was actually the second architect in Ohio. And I've been a LabVIEW champion for 12 years now. So always have fun with that. So what is simple? Let's just start with the dictionary. The first one is easy to understand, deal with, use, etc. This is a great definition for what we deal with, but there's probably more. The second definition, not elaborate or artificial. It's plain. I like this one because it keeps things, it's not ornate. It doesn't have a lot of fluff to it. You just see what it is, and it's very easy to understand. Going down one more, number 5 is not complicated. I think we all know that one. But my favorite was number 14, lacking mental acuteness or sense. This makes people think someone's stupid, but in this context, I look at it as you don't have to think hard to figure out what's happening. It's just obvious. And just for fun, here's some synonyms. Simple, it's clean, it's plain, straightforward. Simplicity, which was how I originally started all this stuff, but simplicity, clarity, directness, it's very direct. Obviousness, easiness. So you keep seeing these easy comes up in these definitions. So those are things we're looking for. But more in our context, what's the goals of being simple? The obvious one is to make things easier. Make it easier to develop, easier for others to help, easier to use, and even easier to support. And then that goes into reducing risk. Simpler designs are inherently less risky. Credit to Steve Watts for giving me that point. But basically, the simpler things are, the less they can break. And also, when you keep things simple, it gives you more time for something else. And I want to point out opportunity cost here. So that's a economic principle that by doing A, you are not doing B. So therefore, there is a cost to not doing B. So by making things simpler for some things, that gives you more time to do things that are more important. And then we all know SMOREs, scalable, modular, reusable, extensible, and simple is thrown in at the end. Generally speaking, by my experience, if you keep things simple, they are inherently more modular and more reusable. Prime example that I found with this one was the pad left function on the NPM. That was back in 2016 when the internet broke, because the developer took away this one 11-line function from the packages, and suddenly everything broke. It's a very simple module, but it was used everywhere. But along with this, beware about making things reusable for the sake of reusability, because my personal experience is that often makes things way too complex. Recently, I had a program where I'm basically doing an RF gain sweep, and I just tried to make things as reusable as possible by putting in classes and all kinds of other weird stuff. But in the end, it wasn't usable because it just got way too complicated to use. So I ended up ripping a bunch of stuff out of it, left just the core intact. So that part was using that is simple. but the rest was then I could just use it and make things how I needed. All right. Then we need to talk about who we're making things simple for. Most people just honestly think the developer, which is you who are actually programming this. I'm assuming programmers in the audience with this one. The customer, who's actually going to use your stuff. So this could be another developer. This could be that person who's actually using your software to test the widget. Just whoever's going to be using it. The maintainers is the person who has to take your code and either upgrade it, debug it, or do something else with your code. And this is likely you in the future. And as Fabiola used to always say, be nice to your future self. Right. And with everything that I emphasize this with almost everything, there's a balance to everything. You can keep things simple, but if they're too simple, they're not usable. And they won't accomplish your goals. So there's a balance to go with everything. So now let's talk about some practical ways we can do things simple. Let's start with requirements negotiations. Good software starts with good requirements. So this is obviously between the developer or the architect and the customer. You're trying to figure out what needs to be happening. Watch out for requirements that are not actually needed. If you can get rid of requirements, that will make life easier on you and possibly even your customer. So what is necessary? What are just bells and whistles? What are just nice to haves? If you can get rid of those, it helps a lot. So this just goes in the send priorities. When I first got into engineering, my dad likes to tell stories about his aunts and uncles because he has a bazillion of them. But one of them actually worked for a toy factory. He was, I think, Kenner. But he was called in, the factory line wasn't working. He would be the emergency guy to come in and make it work. And he would consistently say the first thing he would do is start ripping stuff out, just remove bells and whistles out of the code, and then magically it all works. So he was always the fixer. All right. For those who are doing hardware tests, this is actually a lesson I learned many years ago, but let's think about what we are actually testing for. Are we testing for functional? Make sure every little detail of the spec is met, or are you just looking to make sure the fabrication is correct, that is built correctly? My classic example is back when I was working in the space industry, we were working on a board that was going to go into 5 different boxes. We call it a 1553 module. So it would take commands over a 1553 bus and do whatever with the IO on it. We just programmed each board differently, depending on what box is going into. So we start out the line of, we're going to test every single functionality of this board per what box is going into. And that just turned into a freakishly bad nightmare. We actually had an outside person work on this, and he spent months trying to get this to work, and he couldn't even quite get one of them done because the specs were just too complex. So eventually we decided to punt, and we threw in a test load into all the boards that just toggled the bits, did whatever communications were necessary, and we were able to test all the boards. I was able to program all those, I think, within like 2 weeks. And then probably like another week of integration after that for each one. But by simplifying what the goal was, by testing just the fabrication, that saved us an immense amount of time debugging and integrating and just developing the code. Okay, test equipment. Get equipment that's actually made for your measurements. I've seen too many people try to get an oscilloscope to do a spec in. It doesn't usually work too well. It can work, but not too well usually. And the other example that I've seen a lot is someone will have an RF generator and a spectrum analyzer or power meter, and to do a gain measurement, or you could just use a network analyzer. It just spits out the data for you. So I recommend to get something that's made for your actual measurement. Here. Oh yeah, and if your instrument can do the measurement, let it do the measurement for you. So like oscilloscopes, it has delay measurements. Just let it do the delay measurement. And you just grab that whenever you want. It's a lot easier than grabbing waveforms and analyzing the waveforms and doing whatever. And with that, keep your algorithm simple. So when I was first using LabVIEW, the guy who was supposed to be teaching me, we were supposed to do a message error rate test. So basically an encoder send out a pulse when a command was sent, and the receiver sent out a pulse when it received the message. So basically, if you actually think about it, all you need was to count the two pulses. And then you just divide and you get message error rate. Instead, he decided to hook it up to a DAC to then doing analog measurements on all of those pulses and figuring out states of which one was high at when and whatnot. And it was just way too complicated. And I eventually went to like, why don't you just count pulses? And it would be so much easier. And his exact words, and this is why it's burned in my brain, that's too simple, it'll never work. Of course, I'm sure I looked flabbergasted and I just blurted out, that's why it will work. So keep things simple and they will work much easier. All right. Solutions. So now we're talking overall development. So do not fall for it. It's the way we've always done it. Again, I used to work in the space industry and I heard this way too often. So I had inherited many projects and I said, hey, we can refactor this to do A, B, or C. And they say, nope, this is the way we've always done it. It's just going to keep working. But what I found is this stagnated us a lot. Yes, we kept reusing the same thing, but we weren't actively improving on the tool. We weren't actively using modern practices. And that actually bit us in the butt because later on, we found that there's filled with massive amounts of race conditions due to local variables. So beware of we've always done it that way. But at the same time, balance it with Chesterton's fence. So those who don't know, Chesterton was a contemporary of J.R. Tolkien and C.S. Lewis. There it is. But he put up this hypothetical that you're coming up on a road to this fence in the middle of the road. And he said, what are you going to do? He said, the simple person will just remove the fence and be on his way without realizing that's what the fence was there for. So he was saying that the smarter person will go back, figure out why there's the fence, and then decide whether or not to remove it. So just because we've always done it is a horrible reason, but if there's actually a reason behind that, you need to be aware of that. And with that, use industry standards. They're standards for a reason. For 99% of the time, they're good, they're solid, they're widely used. Just use the standards and it'll make your life easier. But with that, I put on as a UART as the example. There's a program that I worked on, and they said, yes, we're going to communicate over a RS-422 bus. Like, great, we'll just go buy this $50 card and we can talk. Like, no, you can't. Said, no, you can't use that because we are not using UART. Like, but that's when people hear 422 or 232, people instantly think UART. So beware when someone says of a certain bus, you should use what people normally think of that thing, of what that standard is. And NI I'm actually good. I'm happy with NI doing this one, standardized on using gRPC for pretty much all their drivers. I think that's a good way for them to move forward. So I just want to put that one in here. All right. Right. And here's another Steveism. Complexity of the solution should match the complexity of the problem. So this one I just put up there. It's a rocket that I've actually somewhat worked on way back when. This is the Space Launch System, which is Artemis now, I think. It was Ares at one point. It's changed names like 10 times, it seems like. But no one knows actually how a rocket works. Yes, you know some of the high-level stuff. You know some of the parts that go together. But once you get into the nuts and bolts of it, no one understands everything in the rocket. But what they've done is broken down. Okay, we need an engine to do this. We need a box that can pivot the engine. We need stuff to cause explosions, to release a stage. I mean, there's all these intricate parts that no one knows as a whole every little bit. But when you break down the problem, you can bring it together and make. So it's a bunch of simple problems coming together to make for one big solution. So ways of breaking down problems. The obvious one for all of us: sub-VIs and/or test sequences. Those are the obvious ones. Libraries or classes, make sure your libraries are set to do one specific job, like have a library just for the data logger. Features, I see people like break down by features. This is where I find agile sprints useful because you can actually concentrate on one thing at a time during the sprint. So it's more breaking down the problem into individual things that you need. And then this is one I use a lot: separating loops / actors. I'm using the computer engineering term there for a single task. So, and use a common framework is helpful. So I am not advocating for actor framework. I am not a fan of actor framework, but if you use a good framework, it should take care of the complexity of the communications between your loops. So DQMH, actor framework, they both handle this pretty well, in my opinion. But just beware that when you separate things out, you are adding complexity elsewhere. So again, this comes into the whole balance of things. Right. Speaking of frameworks, avoid framework dogma. So this is, I've seen this way too many times. Someone seems to say, oh, here's a framework that we always use, shove everything into it. Like, no, sometimes you can get away with just a simple loop and event structure. So don't shoehorn the problem into a framework. You should find a framework that matches the problem. And then when you do choose a framework, use the rules of the framework. I worked on the only actor framework job I ever worked on. They were actually trying to bypass the communication tree up and down. So they wanted actor A so they wanted two different children of the same actor to talk to each other directly instead of using the rules of going up the ladder and then back down. So use the rules of the framework. And then you also have to be aware of the coupling between your code and the framework. So these are things to consider when you're choosing a framework. How hard is it to test your code? Is the framework even required to run the test? What other dependencies are through this framework? So these are things you need to consider as you choose your framework. All right. Now we'll talk code directly. So goal number one of code, you need to meet the requirements that you're after. If it doesn't do the job that your customer asked, it's crap. But your goal number two, it needs to be understandable by whoever has to read it. So I say that code is a medium by which a human and a computer can communicate. So if the computer doesn't understand, it's going to spit back an error. If your developer can't understand it, he's probably going to throw it all away and rewrite it. So what I say is clarity is just as important as functionality. You could argue almost as important, but if someone doesn't understand your code, it's not worth anything. So you need to think about the developer experience. That's a Fabiola term that she taught me many years ago, and it's one I go back to a lot. But the whole idea is here, don't get fancy, let the code speak for itself, and everyone should know what's happening. You're welcome, Darren. All right, avoid global data. Global data is very hard to keep track of because who knows when it's being updated, who's reading it, and race conditions are very common when you have global data. Even when you try to make it a functional global, there's still the question of who has the data when, and it just becomes a mess very quickly. I'm not saying you can't have global data. There are times when it's needed, but in general, avoid it. Use a wire whenever possible. And this pretty much goes into functional programming. It's something that Weeby likes to talk about a lot. Basically, I take it down to avoid state in your functions. So if you have a sub VI, it should not care what global data, what the states of everything else is. If it's given variables A, B, and C, it should always output X, Y, Z, no matter what everything else is. And it shouldn't affect other things as well. Then use common tools. JSON text by JDP Science, I will swear by this tool. I use it in all my projects. It is a wonderful, absolutely wonderful library. It is great for taking a JSON file or JSON string and converting it directly into my cluster, and vice versa. I have not had a single issue with it after many years of use. It is a wonderful, wonderful tool. It's available on VIPM, so you should use it. I also throw in OpenG. I'm not a big fan of OpenG. I've looked at a lot of their tools. There's a lot of cool stuff in there. I just haven't been able to find a really good use for them without other things. Documentation. This could be opening up a can of worms amongst the people like to fight. I know there's some people that will fight. You must comment every little thing that is happening in your code. And I've seen other people say that your code should speak for itself. I tend to take a middle ground. So free labels, I say describe the non-obvious things. This snippet here, it is directly for a VI I wrote a long time ago now. But basically, I had to take the GPS. I'd given the time, figure out what the GPS time of week was and the week number. So I have a little comment down here saying what this multiplication is for. I left the multiplication in there because it was easier to figure out what it was with the multiplications. Because as soon as I see seconds per week, I instantly know 7 days in a week, 24 hours in a day, 3,600 seconds in an hour. I've done that one enough times. It's embedded in my brain. So yes, this will be constant folded, but for documentation's sake, I left it separated out so I can easily tell. And so that's a simple example using a free label. And label your constants, especially the non-obvious ones. That's what the GPS epoch one. It's shifted due to time zones, so that's why it doesn't look the same for other people. So that's take number one on documentation. And one of my favorite documentation, subdiagram labels. This was introduced in LabVIEW 2012. Loops, if you're putting a loop, describe what the loop is doing. Very simple, quick phrase, 3 to 4 words can usually do it. Just say DAC loop or login loop. So something very simple. If it's top level, I don't usually find it useful, but you can still do it. But case structures are where I absolutely use this and abuse it. So main things to answer. Why is this case being called? So some people would, at one point I was told to put a label on the structure and put in what the question that the structure was answering. In my example here, there's a timeout. So I would put, was a message received? Or was a message not received is actually what would be. And if I wanted to extrapolate on it more, I'd put, was there a timeout? And I stopped using that one and I find it easier just putting subdiagram labels. So in this case, I say, I didn't no command in queue. So therefore, I check the data from the port. So quick, why am I being called? And what am I going to do in this structure? Again, one of my favorite features that's been around for now 12 years. Style. This could open up another can of worms, but whatever. Follow a standard. I'm not going to argue about which standard's best, but as long inside a company, it's best to have a standard of some sort. So what I put in here is the one I originally learned from a style, the LabVIEW style book. written back in 2007 by Peter Bloom of Bloomy Controls. It's a little on the dated side, but there's still a lot of good relevant information in that. I recommend it for any read anyways. And then at GDevCon this last year, Hunter Smith and Tom McQuillan had the Extreme LabVIEW style showdown. It was an amazing presentation. I watched it at least twice, maybe a third time because there was one little bit I actually wanted to make sure I had written down. So that was a very good presentation. I highly recommend watching it. But again, just follow a standard and do some kind of cleanup. Shout out to Sam down here. I put in the blue formatter. I have not played with it at all, but I do trust Sam, so I throw it out there. Play with it, please. Make him improve it. Darren has a similar where he has a Natify VI. So just takes a brand new VI and formats it the same. Yeah, they're basically the same except using CLI. Okay. Yeah, so Darren put in the bit.lys for that one. Or at the very least, use Control U. There's a lot of people that don't like Control U. I personally don't like it. It does a lot of things I don't like. That's just the built-in LabVIEW diagram cleanup. I have my own quick drop that I wrote that did a lot of things similar to Darren's. So sometimes cleanup helps a lot. At the very least, clean up the wires. And use VI Analyzer. This is one of those tools that I knew about for forever. When I used it long time ago, I said, well, this is a lot of noise. There's a lot of stuff I don't care about in this. I was young. What can I say? I started using VI Analyzer for real about 4 or 5 years ago, and my code has massively improved. Let's just say I started using it, and the first thing I noticed after using it is it found a spelling error that had been in my code for years, and it was even in the VI names. So that caused some problems. But thank you, Darren, for making the VI Analyzer. I greatly appreciate it. It is a tool I very highly recommend using. All right, code bloat. So this is code that just gets carried along, whether or not it's used. Basically, don't be a hoarder. I worked for a manager at Radio Shack that was a hoarder, and he went away on vacation, and my assistant manager at the time spent literally a week doing nothing but cleaning out the garbage. Don't be that person. Go through, and Steve, back to Steve Watts, because he's the one that really put me on this one. Go through your dependencies. Figure out where crosslinks are and other undesirables. If something shows up in your dependencies that you don't know where it is, it's likely something you need to investigate. Figure out why it's there. And if it's not used, figure out where you think it's being used and eliminate. And don't be afraid to refactor. This is something that Sam likes to say a lot. We should not be afraid of refactoring. Refactoring can be a very good thing to simplify code, to make it better, to make it more extendable, et cetera, et cetera, et cetera. Yeah, and don't be afraid to delete code either. That's why you have source control. That way, if you do break something, you can go back. And with this tool, Darren Nanninger recently put out to find non-project files. I recently had a place to use it. I forgot about it when I went to do the job, though. But this is a really cool tool. It goes through everything underneath your project. Nanninger. I thought I said it right. Maybe I didn't say it hard enough. Sorry. But the find non-project files, it goes through all subdirectories of your project and finds anything that's not in your project, and you can delete them from there. And then BASVE, I think I said that right, recently put out a tool that will delete a file from the project. GIF, okay, Nanninger, sorry. Some people. Anyways, actually deleting directly from the project is actually quite useful for when you just need to delete. All right. Mutation history. I consider this a form of bloat. If you ever have a question about this, go to ni.com and search for slow editor performance with large LabVIEW projects containing many classes. And you will get this snippet, basically. It'll go through saying, oh, it's because of mutation history. Here, and there's another link for more details on mutation history. But mutation history has also been known to cause errors, build errors, to be more exact. So I tend to clean these out as much as possible. And there's basically two ways to clear out your history: rename the class, and then, or there's two hidden VIs, so they're in VI lib hiding around. Again, the snippet came straight from that knowledge base I linked to above, and you could actually clear out your mutation history that way. When I first discovered this, I went and did that, and I literally saved megabits, like tens of megabits from my executable. And the things actually build a lot faster, I think I found. So clear out that bloat if you find your history is not needed. And please go to the idea exchange, look up make class mutation history optional. It's been up there for probably about a month. Please give it a kudos, because I want NI to make mutation history not needed, that we can opt out of it if necessary. All right. APIs. So this is how someone is going to use your library or code or whatever. Basically, the main thing with the APIs is consistency. Make sure your naming is consistent. Make sure your connector pane is consistent. Make sure your icons are consistent. Consistency makes things easier for your user to use it. And I would even go in and say use objects. At the very least, encapsulation. Encapsulation is a way to hide a lot of stuff behind the scenes that the user does not need. I had trouble digging through code to actually find a prime example of this one. But I do use a good bit where it's just, I need to talk to this guy over Ethernet. I don't care what the IP address is. That's one level, not, so I can just use an object, just pass the object around, and it knows how to get the communication to the serial or whatever. So objects are a good thing for that. Shout out to NI also, new feature in LabVIEW 2024 Q1. The new VI object no longer needs a path to go in. It can use a static VI reference. Make sure you do get the patch if you use this, because there was a bug where at runtime the strict type ref wasn't going through. But this is actually a Vim. I know we're bad-mouthing Vims earlier, but this is actually a Vim that I use in my code. And all this is basically launch or create a VI reference that then can be used to use the asynchronous call by reference. But yeah, this is something simple, and I praise NI for this one. This is a great API update. All right, debugging. This is probably where we're going to spend a lot of time. You or someone you don't want cursing your name will have to debug your code. So let's make debugging as simple as possible. First, easy one. Have probing front panel indicators. In this case, I just have a string indicator saying what my Darren, I was going to mention that, but I couldn't find it on YouTube when I was making this presentation. Yep. So Norm had a great presentation at GDevCon NA this last year, and it is a great presentation. I hope it's back up because it was set to private, and I think it was flat removed. Anyways, having probing front panel indicators is something simple that someone, instead of having to dive into the next level down, in this case, I can just see what skippy string I am sending to my oscilloscope. It is something simple that helps the debugging process. Hidden gem debug write.vim. For those who don't know, go to vipm.io, look up hidden gems and vi.lib, and it will expose this palette that I'm showing here. One of the things in there is debug write.vim. and you can wire anything up to it. And when it gets written to, it opens up this dialog over here. Uh, and so you can have it show timestamps or just the values itself, but it's just spitting out. It's just a way to, it's a simple way to throw in debug code. Uh, use whatever's available. Use log files. This is something that I have emphasized a lot in my time, especially in the last 3 years-ish. Use log files for any error logs, general trace logs. I use them for my terminal communications, which is an example I've shown here. Part of it is blocked out because I didn't want to reveal what this unit's doing. But basically, I put in a date timestamp, and then whatever I receive back from a terminal, I know the terminal has the loop back on. So therefore, anything I actually write will come back. So I can see anything that's happening through this. And with this exact program, the unit that I'm testing also had a debug log. So every time there was a failure, which was quite often, I would make a copy of all the debug logs on the unit and anything I had, and I would go to the head software engineer, and we would step through code and find every single bug along the way. This is immensely helpful. And with the same lines, I save everything I possibly can. If you take a waveform, save the plots. And this one, I'm grabbing an image from, or a waveform from a spectrum analyzer. It's a span 0, so therefore it's actually over time. And then this is actual PNG image that I stole from the code, from the results. Sorry. So people can just look at this and say, "Yep, that looks about right," and they can move on. Or they say, "Hey, we got this funky measurement. Let's look at the plot." Plots are a lot easier to look at than straight waveform numbers. So use that. And here's the code that I basically used. I have a couple of private things that I use in here, but basically, I get the image using oh man, I just an invoke node, sorry, and then save it to a PNG. That's all this is doing. Again, this is code that I use a lot. Oh, and if you use an oscilloscope, most oscilloscopes that I've used have a screenshot or a hard copy to get the image. Use that. It's so much easier. And people very much appreciate when they go to debug. So again, save anything you possibly can. All right, GUIs. Again, keep things simple. Let's avoid the information overload. Use graphs and charts. People are visual beings. So those are a lot easier to look at. The grouping the related data together. And here's a little trick that I learned from other people. Up in here, I have actually the version of the software. That's a nice debug tool. When you come back later, because the user gives you a screenshot saying, here's what we're seeing. This is not right. This way you know that have the right unit or right version of software. If they're way behind, you can give them the updates, or you know they have the latest, and then you move on, or you go and fix it. All right. Okay, I shamelessly stole from Hunter Smith here. He put up this GIF on LinkedIn recently. But format your numerics. Two things I want to emphasize here is use units on your numbers. That helps a lot in the readability. And I really like using metric system. SI is amazing. It helps a lot. It's a lot easier. Basically, I deal with frequencies a lot. So it's a lot easier to see 2.4 GHz instead of 2, 4, then I don't know how many zeros behind it. Because then I have to meticulously count the zeros, and it takes me forever to interpret the number. And it's even worse when I find out that a zero has been added or deleted. And here's the tool I use for that one. So this is a quick drop tool I put. It's actually up on Quick Drop Enthusiast. You look up format numeric. I use this tool a lot. So if you didn't see it, I basically put in hex and converted all my numbers into hex, and I even caused the regex to show. I put in des or bin, and it shows, yeah, if you're a masochist, you can have 64 zeros on your numbers. Yes, I absolutely love this tool. So here's where I was saying before with the 2.4 gigahertz. I hope I did that right. So I can just put in SI, and boom, it's 2.4 G, which is very helpful. A lot easier than seeing a bunch of numbers. Or I can actually put in directly the format I want, and it just goes. And I use this tool a lot, like many times a day. It has saved me so much time. Um, Things are calming down for me, so hopefully this week I can work on getting this on VIPM.io. It is a single VI, but I think it's very useful to put it on VIPM. No, it's currently only on the Quick Drop Enthusiast on the forums, but I will get it on VIPM hopefully this week. I had things for hectic for the last month, so I haven't been able to get it up there. All right. I am running out of time, but I do want to emphasize here that let's try to make life as simple as possible in your own life. So be aware of what is consuming your CPU time. And when I say that, I mean brain, what you're thinking about. Because multitasking is hard. And as I get older, I find it's harder to multitask. I don't know why. It's just what I've noticed, especially lately. So let's refactor out things in your life that are less important. Whether it's video games, social media, podcasts, whatever, just the phone. Let's get rid of some of that stuff so you can focus on more important things. And yes, the definition of sacrifice came from a pastor, I think last year, maybe the year before. Giving up something you love for something you love even more. Which it's one of those that has been in my mind a lot, and I've been working on getting rid of things in my life, and then I can focus more on things like my family, church, just my local community, neighbors. There's way more important things than just code. The people are most important. All right. And with that, do I have any questions, comments, criticism, praise? And I will make these slides available, and there's lots of links in the slides if you didn't notice, so you can find everything through those. I link galore. Will this be quoted as much as a serial one? I doubt that. My serial port nuggets is very much linked to on the forums. So we'll see.